So now we'll go over life tables. Life tables help us measure and predict patterns of birth, death, and survival in a population. Life tables can also show how survival and reproduction rates vary with age, size, and life cycle stage. There are two types of life tables. One is called cohort, which follows the survival and reproduction of all members of a cohort, which is set on all focal individuals in a population from birth to death. The other one is static, so it records the number of living individuals at each age in a population and their reproductive output. So the first one, cohort, is the optimal way to create a life table because it's completely accurate to the cohort, and every change in birth and survivorship are recorded for all individuals at every age. But it's very difficult to collect this type of information. You have to sit for however long they live and watch them. It's just a very complicated process. So the static life tables, which are not the best method as it's not as accurate in representing the population, and it's more of a snapshot, but it's far easier to do and can be done of any organism regardless of their lifespan. So what do these life tables tell us? Well, they tell us population age structure, so how many old individuals are there? Are there a lot of young individuals? How many are at reproductive age? It also tells us population growth rate, so how fast the population is either growing or declining. And then we also have population survivorship patterns. So is the mortality at young or old ages, or is it equal across all ages? In other words, is it type 1, type 2, or type 3? Then when we talk about life tables, we have a few variables to talk about. We have X, which is the age or the stage. We have NX, which is the number of individuals in each stage. We have LX, which is the percentage of the cohort that survives to that age. We have DX, which is the probability of dying during that age. We have QX, which is the percentage of dying, like the percent of dying between ages. And then we have BX, which is the number of offspring produced per individual in a stage. So to go over this, we can see some fake isopod data here. So X, which is in months, so from 0 to 6 months. And then we have N, which goes from 250 to 0. And you can see in the 6th month there are zero isopods left. So you can see for LX that you get this from dividing N by N0, which is the original number at time 0, or 250. And this gives you some survivorship. And then you have DX, which is probability of mortality by taking L and subtracting it from the L at the next older stage. Then you have QX, which is the percent mortality between stages, which is by taking D and dividing it by L at each X stage. So what does this chart tell us? Well, it tells us that they all die before 6 months of age, that a lot of isopods die before they even get 1 month old. And after 1 month, survivorship rate is relatively constant until isopods reach 4 months of age. And what are some problems with some static life tables? Well, there's one problem here on the left, which shows that there are more individuals at age 3 than age 2, which cannot happen in a cohort table. And there's also problem 2 on the right, which there are negative values, which you cannot have negative values for mortality. You cannot get undead. So what does this table tell us? It doesn't tell us too much. We do know that the chickadees die before 6 years old. Survivorship to 1 year is relatively high. Mortality between 1 to 3 years is the most. But we don't have much information on individuals, how many individuals give birth or how many births occur, since we only have a snapshot.